Okay, thank you for coming back. Heat, specific heat capacity. This will be our focus this afternoon. Remember, as you study physics, physics is a logical thinking subject. Alright, so it is very simple as you think logically. And remember, to improve in physics, the best method is output revision, meaning that you will need to answer questions, alright, write down, sketch the drawing, but do not just fall into the trap of reading. At the end of this lesson, I am sure you will be able to solve numerical problems involving specific heat capacity. Alright, quickly let us jump into the question. Look at the question. A solid substance of mass 0.05 kilograms is heated using an immersion heater 240 volts 0.1 kilowatts. And the diagram below shows the heating curve of the solid. Calculate the specific heat capacity of the substance in liquid state. Alright, this is the question. Alright, let me explain a few things as I go along. Number one, there is a specification of the heater. For example, let's say this is the heater in this question. It is said that it is 240 volts, 0.1 kilowatt. Now, 240 volts simply tells us that we need a potential difference of 240 volts to drive this gadget, this device, so that it will give a power of 0.1 kilowatt. So in the calculation of this problem, we are not worried or concerned about the 240 volts. So the power is 0.1 kilowatt or 100 watts. Alright? And what else? The mass of the substance. It is 0.05 kilogram. It has to be in kilogram. Alright? So after that, we look at the question. It wants us to calculate the specific heat capacity of the substance in liquid state. Now, why is it that the liquid state, that phrase is so important? If you look at the curve, 1, 2, I use 3 different colors, 3. Alright? Now, if you look at the yellow line, the yellow line is actually the substance when it is still a solid. The blue line, it is during the melting process. Alright? Melting process, which means that it is in solid plus liquid. And the orange line sloping up, that is where it is in liquid state. Alright. So we are interested only in the liquid state. Alright. Now let's take a look. Let me mark this as, I can call it XY. Alright. I just call it XY. From X to Y, we are interested to calculate the value. Alright. X, Y. Alright, very clear? So I want to calculate what is the specific heat capacity. Now if you look at the equations very quickly, this is one equation that we will need to use. Because the power of the heater is given, we need to calculate the energy because the time is given as well. Now another equation that is important is this. Heat equals to mc theta, where heat is the energy supplied, m is the mass of the substance, c is the specific heat capacity, and theta is the temperature rise in this case. Alright? So step by step, let us calculate now. Alright, the first thing is, let us calculate the energy supplied by the heater. Alright, this is the first step. Energy supplied by the heater. Now in the liquid state, what is the time taken? What is the time taken from X to Y? Alright. And what is the temperature change? Later on, we will have to look at it again. Alright, the temperature change. So the time taken, let's write down, the time taken is actually 1.2 minutes. Now take note, write it down somewhere, because afterwards when I go to another blank page and explain to you, alright, then you will know what the values are. 1.2 minutes, and this will give us 1.2 multiplied by 60 seconds. Alright. And what is the power? I will write it down again. Power equals to 100 watts. Okay. Alright. So now I want to calculate what is the energy supplied by the heater. Alright. Now, so I'm going to make use of these three values. Okay. I know some of you will be jealous of my computer. Alright. Okay, these are the values that I've written, isn't it? Okay, you're happy, I can see. So, I use the equation. The equation is equation power equals to energy divided by time. Energy divided by time. So what is energy? Energy equals to power times time. Alright, now what is the power? 100 watts multiplied by time. 1.2 times 60 seconds. Alright. So I will have my energy equals to this value. Alright. Okay, now I think I'll just leave it as this value. We don't have to multiply because I will use it again in the later calculation. Alright. So that is the first step. Now, the second step is this. I am going to make use of heat equals to mc theta. That is the other formula. Alright, just now I mentioned it. Energy equals to mc theta. Take note that this energy supplied by the heater, and this is the same energy that is used to raise the temperature of that substance in liquid form. Okay? So, in other words, I can actually equate equation 1 and 2. Can you see the point? Alright, I'll do it now first. So, I have mc theta equals to 100. Now, I'm going to write watts as joule per second, because I would like you to see the logic behind it. Okay? Joule per second times second, I get joules. Alright, because energy is in joules. Okay, now what is the mass? 0.05 kilograms. Alright, multiplied by C, multiplied by theta. Now look at the graph. Theta. Alright. Theta is actually the change in temperature. From 78, it goes up to 218. Alright, so what is the temperature change? 218 minus 78, we have 140. Alright, to speed up, I'll just write down 140. 140 degree Celsius. Alright, so this will give me 100 times 1.2 times 60. The unit is in joules. Alright, so in this equation, I want to calculate the specific heat capacity of the substance. Okay, so I write it in red now. So what do I have? I have C equals to 100 multiplied by 1.2 times 60 joules divided by 0.05 kilograms multiplied by 140 degrees Celsius. Okay. Now you can touch your calculator. Use your calculator now. Make sure you check and double check just as I'm checking, double checking my values, and then I will get my answer. C is 1028.57. Alright, to 2 decimal places, it doesn't matter. Now, the units are very important. Joules per kilogram per degree Celsius. So, this is the specific heat capacity of the substance in liquid form. Now, I've taken the trouble to explain to you step by step. So you do that, look at other questions, solve the problems, and then you will understand this section very much better. Okay? So I would like to thank you very much for paying attention to me in this lesson, and may God bless you even as you continue to study. Alright? And I'm Uncle Pang here. See you again the next time round.